Hi everybody. Before I start, LA is so much nicer weather-wise than San Francisco. Okay. So, hi everybody. This is actually kind of a poor title for this talk. It's not really about building React Native. It's about how React Native works and building a library for React Native. So that's what we're going to cover, those two parts. Before I forget, I'm Ari. You can use her on Twitter. I own a dog. You might see her in this presentation. I work at a company called VIRTUALDOM. We produce technical education content, including books like Gbook 1 and 2, and Full Stack React. Today I'm talking to you about React Native, another upcoming book. There she is. Alright. So, she's a lady. Very good. Okay, so we have, these are two books that I'll be giving coupons in the top four, so if you want to stick around and read those. You can probably guess the coupon code. Alright, so yeah, so we're going to talk about how we're going to build a mobile shim to React Native app. So I guess the first, when you're thinking about a talk like this, the first thing that I ask is, well, why do I have apps on my phone and not just use mobile web? And why do you do that? We expect as humans to have fast offline experience with these things, especially since it's no longer dial-up days. I pick up my phone, I better be able to get to Yelp within a matter of seconds. And if I touch the screen, I want the screen to interact. I want to be interacting with the screen, as opposed to using something like Touch.js, where in a website for a good reason, there's a 300 millisecond delay when you start to tap on things. The reason is because Safari doesn't know if you want to scale, if you want to zoom around, if you want to move up and down the page. So that 300 millisecond delay is not a mistake, but it makes for a really unresponsive experience. Whereas screens in mobile apps you can move in under, I think it's 18 milliseconds, otherwise you don't think it's responsive. So another reason why I think that we use native apps and we prefer them over web apps is because we have complex interactions with web applications that we don't necessarily have with web apps, right? You have when do you guys have the Amazon app? And when you tap on that, check out, and then you slide over and that confirms your purchase. That in a web app, that would be really complex to do. We also expect them to be smooth, but there are good things about building mobile apps. So I don't want to. We'll talk about that in a second. The other aspect of mobile web apps, I think why we still build them as opposed to building mobile native apps, is because the development experience is just there's two completely different worlds. You have the if you want to build a native app, you have the native SDKs. And the development model for building a native application, because they're compiled, is you write code, you compile it. If it's a small application, it compiles relatively quickly. If it's a large application, it takes forever. You run on the device, or you run in the simulator, you find a bug, and then you go back and fix it. Whereas you're pixel pushing things over, right? That's at least 3 iterations, and that's 5 minutes. You could have coffee in 5 minutes. You could have gone to the bathroom, picked up coffee, come home, maybe pick up your kids from soccer practice before you had to hit set 4. 5. Let's go to 1. So when we're talking about building native apps, we've been talking about using native languages, Java for Android, Swift and Objective-C for iOS. Specifically what I'm talking about. the experience is really not that great. Also, Cordova, you know, it's just another web view. If you're not familiar with what Cordova is, it's a mobile application built into a native container. So you still have like the web experience in development, but you have a native application, but it's still. There's a lot of cool stuff that you get when you're building a native app or building a mobile app. And there's a lot of problems to deal with if you're. There's a lot of problems to deal with in general when you're building a native mobile app. Covered a couple of those there. So React Native, Facebook comes along and decides they want to build a really awesome framework called React. And they realized, we'll talk about that in a second, that there's opportunity to take what we do when we're building a React application, and instead of just rendering one spot like the DOM, we render it another spot, like, for instance, a mobile app. If you've never written a React app, full stack React, they're 50% off new months, guys. So what I'm talking about is the virtual DOM. So really like overly simplistic view of what the virtual DOM is it's the idea that you can take the slowest part of building or of dynamic web applications out of the process. So the slowest part when you're building a dynamic web application is the changing of the DOM. It's the changing of the view, right? Like you put an element in, you take an element out. That is by far takes the most time. And a lot of frameworks will just do that automatically. React takes a different approach, and instead of building your components and placing them in the DOM and updating the DOM every time one of those components change, it takes a virtual tree of what the DOM should look like. It builds that in memory. You construct these virtual components that React in the React components. You take those and React says, okay, I know where to put this thing, I know how to put this in, I know where this element goes. When something changes, when there needs to be an update, it computes all those changes, and there's a lot of really cool speed things that it does with or performance enhancements that it does. But it computes all those changes as fast as it possibly can, and then when it's all done, then it says, okay, now I can flush this into the DOM. Same thing happens in React Native. But it provides for like deterministic, but this is almost useless example of that. But I know for that React component, I know exactly what is going to go into that component every single time. So React has because the virtual DOM exists, React has the ability to cache a lot of these results and provide a super speedy experience, both for the developer and for the consumer of the application. There's a heavy focus on speed. It's totally open source. React is used all over the world, and in companies that you may or may not have heard of. As I was talking about, the virtual DOM gives the ability for us to take those components that we write on the web. With some translation, we can write those into native components. So just like our component definitions get translated into the virtual DOM, which then gets flushed to the browser DOM, in the native world, those component definitions get turned to the virtual DOM, and then those are flushed to something like, we're talking about an iPhone, UI kit. It works by using JavaScript core, which is it's an open source project, part of the WebKit project, available on both Android and iOS. However, there's trickiness to it, right? Like you have this native set of code, and that exists in its own world. You have this JavaScript set of code, and that exists in its own world. These are two completely different environments. If it doesn't just call, like React Native can't just make a call to a native function every time it wants to make a native function, all because if we're expecting that native function to come back and give us some update about something that happened on the native side, we could be blocked for a long time for the user taking a photo. And, as long as that camera's open, we're waiting for that photo to come back. We can't do anything else. So what it does is everything that runs in the JavaScript side runs in a thread and is focused entirely in the JavaScript core. And then everything that runs on the native side runs in its own thread, usually in the main thread, but we can have other threads as well. And we call back and forth to these threads when we want to make changes, and when we actually build a component, we'll see what that means. Another concern is there's two completely different places for data to hang out. Like, what's the state of the application? Is that on the native side, or is it in the JavaScript side? Like, I can see reasons for both, right? So what React Native does is it bounces messages between the native thread and the JavaScript thread. And it takes these messages and they're serializable messages, so you can send it over the wire. It's really just not good for another thread. The other thing is that you don't want to make as many calls to one thread. You don't want to make a lot of calls to one thread at any time. What if you have, if you're sending text messages back and forth, you want your view to still be responsive, and you still want to be able to update the user's location or whether they're typing or not and messaging them, for example. So what React Native does is it patches all these calls together. Like, it'll take, as you start typing and you're also looking for the location, it will send a bunch of those asynchronous messages using it's called bridge queue, using bridge queues, and then they send those things back. And then they come back. Well, they come back however they come back, but patched one way or here. Yeah. So the development environment for building React Native addresses kind of a lot of concerns that I talked about earlier. It gives us it affords us the ability to work in a really nice JavaScript environment that we all presumably like here. I also like TypeScript, by the way, I might be a 1% here. Yes. But it gives, and you can use TypeScript on React Native, by the way. Not speaking from experience. It gives us like rapid iteration cycles. You'll see that in just a second. There's really awesome tooling. All the tooling, not all the tooling. You get a lot of tooling that you get if you work in React, like Redux that work on React Native. You also get the Redux tool set. You can do backwards and forwards, rewind and reblend stuff eventually. Cool. So let's go through the process of writing a. Actually, before we do that, are there any questions? Kind of like barrel through how React works. No. Orange, you glad I didn't say the hand? Yeah.
How are tests
I use Jest. I use Jest for unit testing, my JavaScript side, and I use either XC test or Kiwi on iOS. But you can still use the same. One of the really awesome things about building React Native, in my opinion, is all your functional testing you can do just however you do within the native application. For unit testing your component, you get the really awesome test setup. You can use Jasmine from the if you're building Android, you have tons of options. Thank you for asking that question though. Hyper tests. Don't tell my co-founder. Okay. So this is the process that you would go through to build a React Native library. React Native has a bunch of libraries for communicating across threads. Let's go ahead and build one. Let's build one that plays sounds. Using the React Native CLI, install the CLI, then you init a new project. and you can create React Native gives the React Native CLI has a new library command that is a really bad command. It doesn't do yet anything great. But with the exception of it gives you a nice little structure, and we're just going to totally change that structure around. So this is how I start this. I started creating a new library. I'm going to call it Sound Machine. And then I'm going to say, forget what you just gave me. I'm going to create a new node module. And then I'm going to copy everything that it generated for me and move it over to the node module. By the way, React Native does not work with symlinks. You may or may not have struggled with this, not speaking from experience. You have to rsync your libraries if they're not in the same directory. So we'll just build it right into the node modules directory. Just remember, don't rm-rf your node modules directory. Yeah.
So if you use something like npm link, that won't work?
Won't work.
Okay. Wow.
Yeah. However, you get a React Native link. So let's actually go ahead and look at our project. This is a demo app project that created. I guess I can. The size. Is that weird that I don't know that? No, it's not. Okay. Can you guys read that?
Yeah.
Can you in the back read that? Really? I mean, I can't read it. Okay, so what we do after you link your project to after you create the npm package and then you run React Native link. What this will do is this will take whatever project we're working on, and it will, for iOS, it will create as a linked library, a linked static library, which you can see right here is my Sound Machine Xcode project. And it will do that for us automatically, and in Android, it will do something else. So we'll talk about that in a second. Okay. Before we get to the native code, I kind of mixed a little bit of this JavaScript. There's a ton of files open for that. Let's talk about the JavaScript side. So this would be like one JavaScript possible implementation of the Sound Machine JavaScript side. In order to, I usually, depending on what is required in my library, I usually have an index file, an index.js file, and use that index file to load the appropriate platform file. One of the things you get with React Native, which is really clever, is I have in this directory I have index.js, and I have two sound machines, an Android sound machine and an iOS sound machine. Now they're the same code, they could be totally different. The React Native will be smart and will load the platform-specific code for you. So by requiring an index.js sound machine, if we're on iOS, it's React Native will load the one with .ios.js file. It's really clever. It's really clever. Okay. I just walked through that. So what we need when we're building a JavaScript API for React Native, the first thing we have to do is we have to have this annotation of provide module. This tells your JavaScript API what the module that we're building is called. I call it sound machine, so provide module sound machine. So I talked about these two threads, right? Like the JavaScript side thread and the native side, but I think I did the other side, the native side and JavaScript. Okay, so from the JavaScript side, you want to be able to make those calls over to the native thread. The way that React Native will do that allows you to do that to import the native modules object from React Native, and then using that, whatever that provides module, I'm sorry, not the provides module, whatever you name your export in React Native will become, you can get access to that on that object. So this will give us access to that native object right there. And actually, while we're doing this, let's load up an application. Alright. So, another thing you get with React Native is this sweet development environment called the Chrome Dev Tools. You may or may not have heard of them. Alright, so just as you show, isn't that native modules thing? Just lock that out. Alright. Oh, also another thing that you get is you get live reload, and we're going to talk about. Alright, cool. So we have all these different modules that we including ours sound machine. There's no ooh ahs. That was like an ooh ah moment. Thank you. LA is so much friendlier than San Francisco. Okay, so in Sound Machine we have one operation. That's the play sound operation. Play a sound using Sound Machine. In our JS API, what we'll do is we'll just call directly out to the native side. I call it the Sound Machine here, and we can just call the function. Because this blue is terrible. That's just anywhere you see that blue, it's just native Sound Machine. Even if you can't see that blue, and you see something after it with a dot in front. All right, so I spend a lot of my time using promises with this asynchronous work in between the two threads. So you could do it this way. You can pass a callback, or you don't have to pass a callback if you don't want to. I like using promises more. So this is like a really naive wrapper around building a promise. However, this does highlight one aspect of how callbacks work on the native side, and that's it uses the error body model that we're so used to in JavaScript, where we pass the first argument is an error if one heard or null if none heard, and then the second argument is the body. So let's go ahead and look at Sound Machine now on the iOS side. This is our play sound function. I'm going to say this slightly differently. Do a little step by step here. So the first thing we need to do is export the module. This is what the module becomes named. Right? If I named it something else, when I go and look at that native modules object that we console logged out, that something else would pop up instead of Sound Machine. But because I passed this name here, that is the name of the module. That's how we get access to it. Are you guys familiar with Objective-C? If I'm like walking through Objective-C, no? You are? Oh, you are? Or is that a question?
No.
We are allotting you with praise. I'm lying, I think. There's gotta be a better adjective. I like that you're familiar with Objective-C. Okay, moving on. Because that was really awkward. Wasn't hitting on you. Just because I'm from San Francisco doesn't mean. Okay. On the Objective-C side of this, we're basically just looking for a sound URL. We're going to find that URL in our bundle. We're packaging a song with our native application, and then we'll use the audio video player to play that sound. And then this is the part that matters, is the callback function right here. This, if we call back an error over here, we pass back we invoke that callback with the first parameter being the error. We don't have to pass anything in the second because we know there's an error. So that promise will get rejected. If there is no error and the audio does actually get to play, then we'll pass null as the first one, and we can pass back an object as the second. Now remember, React Native you don't get access to the native objects in React Native because they are serialized objects. So you have to be able to pass back a plain object, a string, a number, atom. You can pass back objects with atom values, one string keys. They're like arrays will get serialized, but you don't get access to the actual. You can't be like, oh, give me an audio player and then call something on the audio player. So they are serialized. This is back. All right. So we've come to the end of the iOS side. So let's go ahead and actually use this in our application. This is what a React Native application looks like. This happens to also be the generated React Native. Raise your hand if you're familiar with React Native. Do you use it? Okay. So for the 4 of you that raise your hands, this is like the generated application that you're probably familiar with when you create a React Native application. And if you're not familiar with it, this is the generated web app that is given to you when you call the React Native init function or command. The slight difference is we are importing this sound machine from our node module path. Remember we did the maker node modules? We pulled from there. And we're just importing the object. We're swapping with an object. And I added this touchable opacity thing, which allows us to touch the application and have a gesture response. And when we press the button in the running application, it will call play sound. And that play sound calls directly to that function called play sound that we define in the iOS sound machine.ios.js. Calls this function right here. So in the Chrome console, we should see that we get a play sound message because iOS is using promises. Okay, cool. You can see it work.
Yeah.
Yeah.
Oops. I meant to do this. All right, so I'm pretty sure I ran the application. Okay. Wow, that's like, you guys, are you going to clap harder at the end? Or is that like a good way to end on top? You guys look like that?
Yeah.
All right, and then we start my Android emulator up. All right. This thing takes forever. All right, so in Android, you don't have the setup already for you, the new library command yet. A little unfortunate. I'm sure they'll get to it. So generally, what I will do in building a native library is I will copy my application. The reason so the Android side of this is not nearly as clean as the iOS side, right? That looks really nice. This is really scary. So I'll copy my application and delete the irrelevant files for that Android side. Right, let's get this bad boy running. Okay, cool. So we're building an Android library. What you need to do is you need to create a package. In Android, Android uses Java, so we'll create those. We'll create that package in this really ugly folder structure. By the way, all open sources. This will be open source. Probably a user or a full stack EO on GitHub. But I leave my contact information at the end. And if you get me drunk, I'll tell you where I live. Listen, I practice this talk that I'm a recovering comedian, okay? Because you guys were warned. The table of contents. Okay, so we'll create a package, and the package is specifically to tell our Android application. It's to tell our Android application what libraries and what packages it needs to load. Similar to how iOS does it, except for we bundle everything together. In Java, we compile everything together, but we don't bundle it the same way. Obviously, they're different than Ari. Okay, so when we create a package, we can use multiple objects to multiple modules to contain different applications. I don't actually know how to say what I'm trying to say. I'll show you in the example actually. So I worked on a library called FireStack. If you use Firebase, you may or may not be familiar with FireStack. FireStack has in Firebase you have storage, you have cloud messaging, you have a database interaction. So each one of these is added in the module, right? So I have different objects that are concerned with different aspects of Firebase. So you can do that inside of the package. You just basically define what you're going to use. So we are going to spend our time running this play sound function inside one of those modules. In order to use this in our application, we need to go open that really ugly directory that defines a React Native application, and need to list that package as a package that we want React Native to load for us. Without doing this, we can't get access to those native modules. Can't call our native functionality. So being Java, you don't have the same callback style. You have we do get callback objects. These callback objects are given to us graciously by the React API, and they work exactly the same as the callbacks in iOS, in the sense that if you pass a first variable, you invoke it with the first argument being null, it will assume there's an error. And if it is null, then you pass something in the second, that will be what you're about. So that's what that looks like. One more quick thing, we're almost there, everyone. Almost there. If you write something really cool, the community would really love. The community would really love for you to open source it and show it to everybody, show it to the world, and we can all make it better, which is why FireStack itself is open source. So I encourage you to open source your application or your libraries if you do. This is what I guess I don't need to actually go do that. The interesting part about the package JSON in our native module is this RNPM key, and that RNPM key is how React Native link function works. So this is how React Native knows to link up our Xcode project the right way, and the packages instance is how React Native will automatically do that linking for us inside of our Android application. Cool. Any questions? There it is. We didn't. That'd be a free roll, yeah. No. No. Okay. So this error is because we can't find my audio file because I probably copied it to the wrong spot. But easily resolved. But hey, look, the same application on a totally different platform. That was equally as good, if not better, than the first time.
Let's take a trip down memory lane first. Let's reminisce a little bit. So when the web first started, not like the web, like web apps, right? It looked something like this. We were sending HTML from a server to a browser. And people were complaining because every link I clicked, every page would refresh the whole page and I would get a whole new set of data. And this just wasn't good. Like back in the Rails days,